we're going to look at a couple of beginning ideas about oxidation and reduction. First thing we want to look at is the fact that it's very different than the things we've been doing so far with double replacement. Okay, another thing is we want to be able to recognize oxidation and reduction, and we're going to notice that oxidation always happens when there's an increase in the charge or oxidation number, and reduction occurs when there's a decrease in the charge or oxidation number. We're going to make a little note that when you see an element in a reaction, then you know that it's oxidation reduction. And finally, we want to make a definition here about oxidizing and reducing agents. So we have a little picture here of something that's rusty, and rust is iron oxide, and so that is definitely an oxidation reduction reaction. Now, we've been looking at double replacement reactions. In fact, this is one we did in class, where we mix silver nitrate and potassium chromate. So what I wanted to notice here is that when that is mixed, we got a precipitate, and that was that reddish brown silver chromate. But before we started, we had silver ions and nitrate ions, and then and we also had potassium ions and chromate ions. So these are the yellow solution, and the silver nitrate is down here in the clear solution. But afterwards, we had silver chromate, but that's still Ag+, and the chromates are still CrO4 2-. So we can see that it was silver before and silver after, chromate before and chromate after. And the same way, the potassium nitrate did not change. They were both the same ions before and after, and that's not redox. So double replacement reactions where atoms just switch partners, that is not oxidation reduction. Now, single replacement reactions, those are always oxidation reduction. So notice what's happening here is we have silver to start with, and that's Ag+ in the silver nitrate, but afterwards it's silver metal. We can see that's forming here in the solution around that piece of copper. So that's silver metal. A lot of times we put a little 0 just to remind us that that is neutral silver, not silver ions. And the same way, here we have copper, okay, to start with, and that was copper metal. And then we get copper ions, and we can tell that because of the blue solution. So the copper metal turned into copper ion, so it's actually changing its number. And because it's changing its number, we can see that that is oxidation reduction redox. And one little note we want to make about this, and that is whenever you see an element in a reaction, you know that that has to be an oxidation reduction reaction. Now, when we get to synthesis and decomposition reactions, those could go either way. So in our first example, here's copper carbonate, and that's what we have in the tube, and if you heat it, then it will break down into copper oxide and CO2 gas. Now, if we go through and look at all the numbers, all the charges and oxidation numbers, then nothing has changed. So this is a non-redox reaction. But another decomposition reaction is peroxide, which broke up to be water and oxygen, and we saw that in the micromole rockets. We use that as our oxygen generator. And here we see the elements, so we know that this is redox. So when we have decomposition reactions, and we could just do synthesis by turning these around, they could be either redox or non-redox, so we have to be a little careful with those. Now, just to sum this up, we've seen double replacement reactions. Okay, those are never redox. Single replacement reactions, those are always redox. And if we have a synthesis or decomposition, it could be either way, and you have to look at that kind of carefully. Now, how do we recognize whether something is oxidation or reduction? We look a little closely, and one of the ideas for oxidation is that the charge increases. So here we have silver ions turning into silver metal, and we have copper metal turning into copper ions. So we can see that the copper is being oxidized and the silver is being reduced because it's going from plus to 0. So one thing to watch for is what's happening to the charge. When the charge is decreased, that's reduction. When the charge is increased, That's oxidation. Now, why does the charge, let's say in the silver, why does the charge get reduced? And that's because it's gaining electrons. In this case, gaining 1 electron, and if we balance, it'll be 2. And in the copper, we can see that its oxidation number is going up, so it must be losing electrons. So that's another idea here, and that is anytime we see oxidation, we're losing electrons, and we're doing reduction, we're gaining electrons. And the mnemonic we saw in class is Leo the lion says grr, losing electrons is oxidation, and gaining electrons is reduction. Now the last little idea is there's a terminology called the oxidizing and reducing agents. So here we have zinc, and zinc is being oxidized, going from zinc neutral to zinc 2+, and the hydrogen ion is being reduced. Now we could say that zinc is oxidized and the hydrogen is reduced, or we can say that zinc is oxidized and that the hydrogen is the oxidizing agent. In other words, that is the chemical that allows the zinc to get oxidized. Okay, why does it allow it to get oxidized? To be oxidized, you have to lose electrons, and the hydrogen is there to gain the electrons. So hydrogen allows the zinc to be oxidized. Now in the same way, we can say that the hydrogen is being reduced, and therefore the zinc is the reducing agent, because it's the chemical that is allowing the hydrogen to be oxidized. So it's actually pretty simple. It's kind of backwards, but pretty simple. Whatever gets oxidized is the reducing agent. Whatever gets reduced is the oxidizing agent. And that's all.